Hi students, in this video we want to see about the orthogonal projection. In that we want to deal about the projection of points in the different quadrants. In the previous videos we have seen the introduction to our engineering graphics as well as the software which you are using for the engineering drawing. So coming on to the orthogonal projection. So the projection points is must be following the information should be there to draw any of the projection over there. That is the one is the object with its description and well defined. It has to be defined in a proper way. Coming to the second one, the observer. So always observer perpendicular to the reference plane should be there. Then third one will be the location of the object. So it is the position with respect to the horizontal and the vertical plane. In the previous video, I explained about the three major principal planes, that is vertical plane, horizontal plane, and the profile plane. So coming to the points to be remembered, the first one is a point in the space to be defined by a capital letter. If you have a point A should be a capital letter. The projection obtained on the horizontal plane is called the top view. Means when you're going to observe from the top, it will be drawn onto the horizontal plane. So it will be on the horizontal plane. When you're going to observe from the front, it will be projected onto the vertical plane. So that will be denoted by a small letter with a dash on the top, whereas the top view will be denoted by a small letter. The projection on the profile plane will be called as profile view. That is nothing but a side view. Either it may be right side or left side view. And it will be denoted by a small letter with double dash. So based on the position of the observer, the coordinate will be defined. But the observer should remain in the fixed position. So as I said in the previous video, the observer can be either from the right hand side or left hand side. Based on the position of the observer, the coordinate position will be changing. So to keep all those views in a single layer or single paper, we're going to rotate the horizontal plane for 90 degrees as well as the profile plane for 90 degrees based on the quadrants. Coming into the things, so these are the all four quadrants. So that is vertical plane, green color indicates vertical plane, orange color indicates the horizontal planes, and XY line indicates exactly the intersection of vertical plane with the horizontal plane. And the front view will be always drawn on the vertical plane and the top will be drawn on the horizontal planes. The observer I'm going to fix on the right hand side now. So whenever the observer in the right hand side, so whatever the points I'm going to keep, let me take any of the point over there. So if I want to keep an object over here, so this is in front of VP and above HP, then I'm going to term that one as the first quadrant. The second quadrant, if I'm going to keep the object over here, which is behind VP with respect to the observer and above HP. So whenever the object is above HP and behind VP, I'm going to term that one as the second quadrant. Coming to third quadrant, so if I want to keep the object over here, which is below and behind. That is, whenever the object is below HP and behind VP, we term that one as the third quadrant. If I take the object over here, which is below HP and in front of VP, then we know that the object will be in the fourth quadrant. So this is how it's going to replicate. The first quadrant, the second quadrant, third quadrant, and the fourth quadrant. So the observer is kept over here. If the observer is observing from here, this becomes the first, this becomes the second, third, and the fourth quadrant. So it defines the coordinates will be defined based on the observer. So you have to fix the observer first, then you have to start. So now I'm using the observer on the right hand side. I'm going to define from the right to left. I'll go for the anti-clockwise direction of defining the coordinates. So over here, again I'm repeating that first quadrant, the definition will be above HP in front of VP. Second quadrant, above HP behind VP. Third quadrant, below HP behind VP. The fourth quadrant, below HP and in front of VP. So now we'll see how individually you can project the points in different quadrants. So let me take the projection of point in the first quadrant. So let me assume the first one. So this is the problem I assume. So I kept a point A over here. This is the point A. So I want to observe from the front. I want to project the point A onto the VP plane. So I'm going to get another point over there. That point I'm going to specify as A dash. So as I said, the front will be always defined by the small letters with a dash. So I'm going to specify as A dash. So when I want to observe from here, I can see how much distance is above HP. So the same distance I'm going to take on a vertical plane and I'm going to draw A dash. So when I want to observe from the top, I can see how much distance it is in front of VP. So I'm going to project A onto the horizontal plane. So I'm going to get a point A. So this distance will be equals to the distance from VP. So now this I can't show in a single paper. So this is the method I'm going to follow. For that, what I'm going to do is I'm going to rotate the horizontal plane for 90 degree in the clockwise direction so that it comes and merges with the VP. So when I'm going to rotate that, the horizontal plane will be exactly below the vertical plane. So when I'm going to take the intersection as XY, so this is the XY. So the VP will be above and HP will be below. So the distance is 15 mm. So I'm going to take 15 mm and from here 20 mm. So always the front and the top view should be in a straight line. So I'm going to get A dash and A over here, 15 and 20 mm based on the definition. So what I'm going to do is this, I'm going to remove the boundary of vertical plane and horizontal plane, and I want to normally say that whatever things are above XY line as VP, whatever things are below XY line as HP. So whenever you're doing the projection in the first quadrant, always you have to specify this as VP by HP. So the front view always will be at the above XY line and the top view will be below XY line in the first quadrant. Coming to second quadrant. So second quadrant definition is above HP and behind VP. So when I am going to take, the object over there, so when I'm going to take the object over here, so this is the object which is behind and in behind VP and above HP. So I'm going to observe this. I have to go backward direction of the projection. I'm going to project this. I'm going to get as B dash, and I'm going to observe for the top. I can get the B onto the horizontal plane. Now this is B and this will be your B dash. So now what you're going to do is you have to rotate horizontal plane again for clockwise rotation for 90 degrees. So they are specified over here 90 degrees. So I'm going to rotate. Here when you're going to rotate for same direction, what will happen? HP comes and merges with VP. So both horizontal and vertical plane will be in the same position. So you can see over there, the intersection line is going to show as XY line and both VP and HP has merged over here. So again, I'm going to remove the boundary of this. So what will happen? So both HP and VP will be above XY line. And here in the second quadrant, none of the image or projections will be below XY line. And here again you can see the difference between the front view and the top. You can see the dimensioning. So dimensioning, I used a unidirectional dimensioning over here. Coming to third angle projection. So third angle projection is nothing but projection third quadrant is nothing but the definition will be below HP and behind VP. So the object is kept over here. Okay, so when you're going to rotate that, so what is the position you're going to get? So here again the HP will be rotated for 90 degrees. So what will happen? HP comes above VP now. Since already VP is at the bottom and the object is below HP, the HP goes to the higher position, that is above XY line, and VP comes in the below XY line. And in this case, the top view will be at the top and front view will be at the bottom. If you take the first angle, the front view will be at the top and top view will be at the bottom. So you can see the first, so just it is opposite to the third angle of projection. So that is the difference. When you're going to take the first angle projection and third angle projection, assuming the first quadrant and third quadrant. In the first quadrant, I'm going to get front view at the top and top view at the bottom. Whereas in third quadrant, top view will be at the top and front view will be at the bottom. So and the representation will be HP by VP. Coming into fourth quadrant. So fourth quadrant, I have to project the point. So I'm going to assume a point B over here. So this is the point B. So which is below HP in front of VP. That is the definition of fourth quadrant. So again here, when I'm going to observe from the front, I'm going to project the B onto the B dash. And when I'm going to take from the top view and the plane is in between the observer and the object, I have to go for reverse projection, and that is towards the upwards. I want to get point B over here. And here again the HP has to be rotated for clockwise direction only. Since once you've taken the right hand side as your observer as the right, and from the right hand side, it has to go in a clockwise direction. If you are assuming the observer from the left hand side, the HP plane will be rotated in a anti-clockwise direction. So I want to rotate that. So what will happen? Both HP and VP comes and merges in the same place. So both the horizontal and vertical plane will be below XY line. So I'm going to get both front view and the top view below the XY line. So this is just exactly opposite to the second quadrant which you already done. That is, both the front view and top view will be above x line, and here both top view and front view will be below xy line. You can see from the four quadrants that second and fourth quadrant, it is very difficult to do the projection because all the projections will be either above or below the xy line. It is very difficult to identify which is front view, which is top view without having the notification. Whereas when you go for the first quadrant and third quadrant, easily I can identify which is top view, which is front view. And if you know the front view and top view, I can identify the right side view or a left side view of the object. So that's why they are using first and third quadrant instead of any second or fourth quadrant. So coming to the major thing you have to remember is the distance of elevation of point from xy line is equal to the distance of a point from the horizontal plane. So how much this is above, that is the elevation. So that is always with respect to the horizontal plane of projection. If the distance of plan, when you want to observe from the top, I can see the plan. So that is nothing but the distance of the plan is nothing but the distance equal to the point from the vertical plane. So these are the points to be remembered. So we're going to solve the problems in the further videos. Thank you.